looking at more useful terms that are used a lot in chemistry. Next, let's look at isotopes. Isotopes are atoms of the same element with different mass numbers. So they have a different number of neutrons. As we were looking, the atomic number that's going to be the smaller of the two when you see a chemical symbol, that's the number of protons. So notice that carbon here, all represented by C, has 6 protons in the nucleus. But see how the mass number changes for these isotopes. So if we're subtracting 6 from 12 here, the carbon 12 has 6 neutrons. Carbon 13 has 7, 13 minus 6, and carbon 14, which happens to be radioactive, has 8 neutrons. So isotopes will be named according to their mass number. Certain isotopes of some elements have unstable nuclei and throw off high energy radiation as they decompose to a more stable form. So radioactive isotopes emit various types of energy as they decay. This energy or radiation can be used for different purposes, such as medical imaging. So radioactive iodine gives off a certain frequency and can be then imaged. So here, showing the thyroid gland which takes up iodine, and if there's a portion on a scan that does not show that, could represent a tumor. So a PET scan, or a positron emission tomography, can reveal areas of the brain that are most active. And again, this is uses of low-level radiation. We may already associate radiation with death, and that's a correct association because too much radiation can kill cells. If, however, you can direct this radiation where you want to, you can kill off cells like bacteria and fungi if you irradiate peaches or other produce, or radiation therapy to kill cancer cells. Ions form when there is an unequal number of electrons and protons. So we're looking at variations on those subatomic particles that we talked about. We had protons, neutrons, and electrons. So different number of protons, you get a different element. If you have the same element but different number of neutrons, you get isotopes. And so here it's going to be a variation in the number of electrons and protons. We talked about how in a neutral atom you have a charge balance, so you have an equal number of protons and electrons. With an ion, this is a charged atom. So it's going to be either losing or gaining electrons. If an atom loses an electron, it will have a positive charge. This is because now you have more protons than electrons, and hopefully we're remembering that protons have a positive charge. For example, sodium, represented here by Na, when it is uncharged, it has 11 protons and 11 electrons. If it loses an electron, you have positive 11 protons plus negative 10 electrons for an overall positive 1 charge. This is going to be represented as sodium with this positive 1 in this upper right hand corner here. So that's how you'll know if something is an ion. You'll see some kind of charge there. So on the other hand, if an atom gains an electron, it will have an overall negative charge for the atom. This is because electrons, which are negatively charged, now outnumber protons, which are positively charged. So our example, chlorine, represented by Cl here. If it's uncharged, you have 17 protons and 17 electrons. If it gains an electron, you have positive 17 protons plus negative 18 electrons for an overall negative 1 charge. And this is represented as chlorine with a negative 1 charge here. You can lose more than 1 electron or gain more than 1 too, and so that will be represented by either a positive 2, positive 3, negative 2, negative 3, etc., letting you know how many protons versus electrons you have. So it's kind of this loss means positive charge, gain means negative charge. But if you keep it straight that electrons are negatively charged, this will make sense. So now that we've looked at some important terms and how atoms are arranged, we can start looking at molecules and compounds. Even though atoms can exist by themselves or bound to an atom of the same type or element of the same type, most of the time we're looking at compounds and molecules. So molecules form when two or more of the same element bond together. For example, the oxygen that you're breathing right now that's in the atmosphere is one oxygen bound to another, represented as O2. Compounds are going to form when two or more different elements bond together. So water, represented as H2O, we have hydrogen and oxygen bound together. When a chemical reaction occurs, energy may be given off or absorbed because of the energy that's present in bonds. So we're going to look at 3 different types of chemical bonds. The first one being ionic bonding. So we just talked about what ions are. They form when electrons are transferred from one atom to another. So you have some kind of charge on an atom, and there's going to be a resulting attractive force from that. So for example, like we were just looking at, sodium has 1 electron in its 3rd orbital if it's an uncharged atom. And so it tends to be an electron donor. So thinking back to that octet rule, it's easier to give up 1 electron than to gain 7 more. So sodium tends to become positive after giving up this 1 electron. Chlorine, on the other hand, has 7 electrons in its 3rd orbital, so it tends to be an electron acceptor. And again, that octet rule, easier to gain 1 electron than to give away 7. So chlorine, if it takes up an extra electron, it's going to become negative after gaining that 1 extra electron. So looking at how this happens, sodium, normally uncharged, if it gives up this 1 lowly electron in its 3rd orbital and chlorine takes it up, then you have a sodium ion and a chloride ion, and now there's this charge imbalance, and it's this attraction between positive and negative that creates an ionic bond. So again, after the transfer of these electrons between sodium and chlorine, both the sodium and chloride ions have 8 electrons in their outer orbital, satisfying that octet rule. Ions now have opposite electrical charges. And ionic compounds that are held together by an attraction between oppositely charged ions is called an ionic bond. So the key here is ions are formed, and there's a transfer of electrons, and it's that attraction between positive and negative. So sodium chloride, by the way, is common table salt, and if you look at the crystalline structure, it forms cubes. And so this is an artist's representation of that ionic bonding between the sodium and chloride ions.